Hello. Today I'm going to be talking about the history of the periodic table after reading a book by P.W. Atkins called The Periodic Kingdom. So, the discovery of new elements has depended on technologies always, and once these elements were found, it helped find other elements. For instance, iron was necessary to find titanium, and the technology that helped find iron was fire. Nowadays, we just take a sample and atomize it, and then we weigh the atoms. However, some elements can be found in nature, such as gold, copper, and sulfur. You don't have to do anything special. They take their form and they are there. Potassium was found by using electrolysis, which is sending currents through matter to break it down. So, in order to find potassium, currents were sent through caustic potash, and thus came potassium. And a fun fact, many elements were found after the Manhattan Project, which was a nuclear bomb building project during the war. And this helped find the actinide metals, which include uranium and plutonium, the more reactive elements, nuclear reactive elements. The next section in the book discussed how elements achieve their names. So, for one of them is magnesium, which came from ores obtained from white earth, which is called Magnus Carneus. And this was discovered in Magnesia. So, magnesium, magnesia, it's relevant. Another way an element gets its name is based off its color. So chlorine is a pale yellowish gas, and it comes from the Greek word chloros, which means yellow and green. Another one is rubidium, which is kind of tricky because it stems from the Latin word rubidius, which means deep red, but the element appears to be a metallic gray. However, when you burn it, it gives that deep red, so it stays true to its name. One more way that an element achieves its name is through smell. So bromine derives from bromos, which means stench, given that name because bromine is smelly. Lastly, elements can be named after those who found it and the gods. So, for instance, Albert Einstein has Einsteinium, and Dmitri Mendeleev has Mendelevium, and Prometheus has Promethium. The next section discusses the origin of most elements, and all elements came from the Big Bang. So when that happened, many stars were created, and these stars would produce heat and die out. And nuclear fusion is a coalescence of protons and neutrons to produce more complex and a more massive nucleus, giving us new elements. So when stars would die, they would let off some new elements. The last section in the history part of this book is the cartographers, and unfortunately I am not going to try to pronounce their names, and I will put their names on my images. So the first serious cartographer of the periodic table was a German chemist, and he used the law of triads, which is a numerical base, and he saw a pattern with the elements. For instance, he identified iron, cobalt, and nickel, elements 26, 27, and 28, with atomic weights of 55.85, 58.93, and 58.69. Those were a triad. The next person to try to organize the periodic table was a French chemist in 1862, who arranged the elements on a spiral inscribed on a cylinder and managed to accommodate 24 elements. He noted a periodicity of properties with similar elements recurring after every seventh element, so instead of 3, it was now every 7. In 1864, a two-dimensional arrangement thought of by English chemist John Newlands took place, and it accommodated 35 elements. He proposed that elements lay on octaves. When he arranged the elements according to the masses of their atom, that is, their atomic weight, he found that every eighth element created a harmony. Next up was William Odling, and in 1864 he placed 57 elements in locations we recognize today, but some of them were just placed there or not properly identified. But he also left gaps which strongly suggested that the existence of missing elements were out there. Finally, on February 17th, 1869, Dmitri Mendeleev came out with the final form of the periodic table. Basically, the final form. Mendeleev argued that the atomic weight was the only fundamental characteristic of an element because it was independent of temperature and other variables. He found that by arranging the elements in order of increasing atomic weight, he captured similarities. Today, the vertical columns are groups and the horizontal rows are called periods. He charted only about 32 in his first attempt. He ignored the masses of the atoms in this case and used his nose to assign the elements to their appropriate groups. Where gaps were needed to make elements belong, he left them. As we've seen in the existence of these gaps pointed explorers to the discovery of unknown elements. The modern map of the periodic table has detached itself from the tyranny of atomic weight. The elements are no longer listed as masses, but by a much more fundamental quantity, atomic number. The atomic number of an element is the number of protons in the nucleus of one of its atoms. The number of neutrons, which of course contribute to its atomic weight, are ignored. And that is the history of the periodic table.